yesterday, some of us. We took a monomial on the outside of a set of parentheses, and we distributed it through a trinomial. So we had one term on the outside, we had three terms on the inside, and we ended up with a three-term answer. We did the three Hangman spaces. Okay, just a reminder of what we did yesterday. Today we're going to talk about multiplying binomials. Now a binomial is a polynomial with two terms. So we're going to take, you guys, I am going to get to example 1 right now, so don't write anything, just watch. I'm going to take a binomial, x minus 5, two terms. Carter, do you think you should pay attention?
Yes.
And I'm going to multiply it by another binomial.
It's like one of your examples.
This is one of my examples. There's nowhere to write it, so just watch right now. Watch the board right now. Okay, there are two terms here, and we're going to multiply them by two terms over here. Keep your change quiet, or I will confiscate it.
You're gonna take all your money. You're gonna be broke.
2 times 2, a binomial, which is two terms, times another binomial, which is two terms, actually gives us 4 terms. Because it's 2 times 2, that gives us 4.
So if it was like there was 3 terms and then 2 terms and 5 terms.
It'd be actually 6, because it'd be 3. Yeah.
Okay.
Yeah. So, and that's what we'll be doing on Monday. We'll be taking a binomial times a trinomial. So we'll take a 2-term times a 3-term and get 6 terms out of the deal. Now, that doesn't mean we're actually going to have four terms here in our answer, because some of these terms are going to be like terms when we're done, and we can add them together. So let's take a look at what we get from this. We're really distributing twice. So we call it a double distribution. So this term right here, if I cover this up right here, pretend it doesn't exist, and I distribute it through, I would take x times x, and I would take x times 7. Everybody okay with that?
Yeah. So you just forget about one.
Okay. Now I'm going to unlock this guy, because we are going to back the train up. And this time,
You're gonna take x times negative
we're going to cover the other guy up.
5 times 7.
We're going to call it negative 5. We're going to take that minus sign as a negative. Negative 5 times x and negative 5 times 7. Does that make sense?
Yeah. So you cover up like one of the first.
Now, here's actually what we're doing though. Think about it this way. If you notice, see how there's an x here and an x here? We used up that x. It goes twice. It gets used twice. Then we have the negative 5, and that's used twice. We have the x over here, that's this guy and this guy, that's used twice. And the 7 is used twice.
So each of them should be used twice.
Each of them is going to be used twice, and they're never going to be multiplied by its own buddy in the binomial. Does that make sense?
So let's say you took your term.
Yes.
It doesn't matter which side you come from. Like,
Like negative
if
5.
you did like
It would,
7 times negative 5.
no, it's not going to make a difference there. But eventually, I'm going to show you this this FOIL method, which is a way to keep track of these things without having to cover up one piece or the other. Okay, so another way to think about it. All right, so you guys, we gotta simplify it. What's x times x? X squared. What's x times 7? What's negative 5 times x? What's negative 5 times 7? Now, those are our 4 terms, but do you notice anything about some of the terms? These two have the same variable to the same power. They're like terms. We can add them together. What's 7x minus 5x? This answer is x squared plus 2x minus 35. That's what the answer to this is. Okay, does that make sense a little bit?
Yeah.
All right, we are going to go ahead and do this, this first example. So you might want to write this down as we go. So there's a 2 by 2. So I'm going to write this big, 2x plus 3 times x plus 4. And yes, I'm going to do this on the board first. So I'm going to cover this up. And we're going to distribute that 2x through. So what do we get? 2x times x. Here, I'll show that stuff. So 2x times x and 2x times 4. I've used that 2x twice now, right?
Yeah.
So I can cross it out because I only have to use it twice. Now I go to the next part of that binomial, the 3. I haven't used the 3 at all yet. So now I'm going to take 3 times x and 3 times 4. Have I used everything only twice?
Yeah.
And exactly twice.
Yeah.
Then I can go ahead and simplify this problem. So I have 2x times x, 2x times 4, 3x, that's easy. Now, can anything get together? The middle term. So we have 2x squared plus 11x plus 12 is my final answer. Okay, now one way to look at this problem is called the FOIL method. Yes, guys.
Okay, so when you did the 2x times 4, I thought you went slow because the 4 doesn't have x.
You can't add them. You can multiply anything. You can't add them. All right, so you guys, another way to look at this distribution thing is by using what's called FOIL. So, yeah, I'm going to use the space up here. And I'm going to make up a problem again. Well, let's just do that one, huh? 6h minus 7 times 2h plus 3. So you see this FOIL? We have 4 spaces. We know we're going to do 4 different multiplying things. The F stands for firsts. So that would be the first term of the first binomial times the first term of the second binomial. So those are the firsts. So that's first. So 6h times 2h. Then we have O, which stands for outer. So the outer 2 terms of the whole shebang, the outsides, which would be 6h times 3. Now notice when I'm multiplying by that first term, I'm using down loops going below. This is how I keep track of my terms. So here I did 2 loops underneath. Now we get to the inner, and that means I'm going to use this guy and this guy. Now when I get to the -7, I do my loops up above. I have 2 loops on this bottom side. I have 2 loops on the top side. That's -7 times 2h. Remember that minus sign always goes with the guy behind it. So it's like a -7. I have the last one, which is the last term of the first binomial times the last term of the second binomial, which is -7 times 3. Now, we did the exact same process as when we thought of it as double distribution. It's just whichever way it's easier to process and think about it and remember is what you use, okay? So if something says use the distributed method or use the FOIL method, it's really the same thing. Just use whatever way you can think it through the best. Okay, so let's simplify this out. What's 6h times 2h? 12h to the second. 6h times 3. -7 times 2h. And negative. Wow, okay. Yeah, but I wasn't thinking either. And finally, -21. Now, notice this was our first, this was our outers, this was our inners, this was our last. Notice the OI can be simplified. That happens a lot, not every time, but a lot. A lot of times you start with the 4 terms, but then the 2 middle terms, the OI, are like terms, so your end answer is only 3 terms. So we would have 12x squared, h squared, plus 4h minus 21. Yes, Alex.
How's the FOIL different from the original one?
It isn't different at all in any way other than a different way to remember it.
Okay.
So whichever way will help you remember the best, either do distributive or FOIL.
Okay.
The same thing.
Same thing. We actually did things in the exact same order. I mean, everything was exactly the same. It's just a different way to remember. Okay, so you guys, we got 2 more examples just to run through and make sure it's good, and then you can start working on your assignment, okay? This is it. Okay. So, do you want to do FOIL or do you want to do distributive? Distributive. Okay, so let's cover this up for now. And let's just do this. 3x times 2x. To the second, don't forget that square. 3x times 7. 21. All right, it's done its job. Let's get rid of this. Let's go ahead and cover this up now. And remember, that's a -5 really means -5. So take that sign with it. -5, -10x, and
-5.
the O's are alike.
Subtract or add them?
Well, it's a +21 and a -10.
So.
So do 6x squared plus 11x minus 35. One more, just because they're that much fun. Just because some people weren't paying attention. Okay, so
this is hard.
it can be, especially if you don't watch. Think about it this way. This is how I explained it, or this is how I introduced it to the other two classes, and I didn't do this with you. I said, what is x minus 5 times x plus 7? Give me some ideas. What do you think it would be?
No idea.
Lexi, wake up.
I literally, I know, that's right.
If I hadn't taught you FOIL or the double distribution process, what do you think that answer would be?
2x minus 5. Times x plus 7.
The closest they came was this. They did this and this. That inner piece wasn't as obvious. It's something that you wouldn't normally think to do. That's why it's hard, because it's not intuitive. It's not like something you would look at and go, oh, yeah, that makes sense. It does after I teach you. But if you were just to look at this and you didn't pay attention to my lesson,
It'd be hard.
it would be very hard. That's why they pay me.
That's why the lessons are so important to watch them. Like on Wednesdays.
Right,
Yeah.
right.
2 because double lessons.
Okay, can we finish this last one and then you guys can work?
Yeah.
Okay, so. I feel like you are out of your seat more than you're in your seat.
I'm trying to tie my shirt.
Okay,
No, but you're gonna get dressed in it.
so you guys, do you want to do, let's do FOIL this time. You guys, we're gonna do FOIL this time. Okay. First. First.
6x squared.
Outer,
3x
which is
negative 59.
perfect. Inners, I'm gonna go up above.
Negative 4 times 2x.
Uh-huh. What is it? And finally, positive 20, because there's 2 negatives, right? These two, the O's, are alike.
Negative 22.
There's our answer.
Are you adding?
Yeah, you add them together. Negative 15 plus negative 8.
Oh, wait. You always
add the middle.
Okay, hold on. Yeah, well, in this case,
Negative, I
Only
just
after
added
8 was
negative 15 minus 8.
same thing.
Okay.
Negative 15 plus a negative 8 is the same thing as negative 15 minus 8. So you can do either one. All right, you guys, your homework then is 9-3A worksheet. On Monday, we're going to keep it up a notch. We're going to do a binomial times a trinomial.
Are we
So
gonna
make
always-
sure you understand how to do this part because we're going to raise it up a level.